Hi, welcome to Learning Space. I'll be explaining you the latching and holding current of a thyristor. It is very essential to understand the latching and holding current of a thyristor in order to understand the operation of a thyristor very clearly. Before going to explaining you the latching and holding current of a thyristor, let us recollect some of the basics of a thyristor. If you look at the structure of a thyristor is a three-terminal 3 junction 4 layer device. When anode is made positive with respect to cathode, then thyristor will get forward bias. When thyristor is forward bias, then junction J1 as well as the junction J3 will get forward bias and junction J2 will get reverse bias. When the junction J2 get reverse biased, then there is a deflection layer across the junction J2. In order to make the thyristor to turn on, the deflection layer developed across the junction J2 can be removed. This deflection layer across the junction J2 can be removed by different turn-on methods. One of the reliable turn-on methods of a thyristor is gate triggering. By gate triggering method, we can apply the gate current through the gate terminal so that gate current will remove the deflection layer across the junction J2. Then current flows freely from anode to cathode terminals of a thyristor. Then we say that thyristor is turned on. By taking this background into consideration, let me explain you the latching current of a thyristor. Let us move to next slide where we will see the latching current. First, let me explain you the definition of the latching current. It is the minimum value of the anode current which is required to turn on a thyristor after removing the gate signal. That means when the gate signal is applied to the gate terminal of a thyristor, current passing through the thyristor increases and it reaches the minimum value. That minimum value of the thyristor current or anode current of a thyristor can be called as a latching current. That means to keep the thyristor in conduction state, the current passing through the thyristor should be more than this minimum value of the anode current, that is the latching current. This latching current is associated with the turn on process. It is in general 2 to 3 times the holding current of a thyristor. What is the holding current of a thyristor? I will be explaining you in the next slide. The latching current is in milliamperes. The magnitude of the latching current depends on the rating of a thyristor. Once the anode current becomes more than the latching current, then no more gate pulse is required to keep the thyristor in conduction. That means gate loses its control. Thyristor will continue to conduct irrespective of the gate current. So that's why thyristor can be called as a latching device. Now let us see the holding current. First, let us see the definition of this holding current. It is the minimum value of the anode current of a thyristor below which thyristor turns off. That means if the thyristor is in conduction, if wanted to turn off a conducting thyristor, the current passing through the thyristor should be brought below the holding current value. To bring the current passing through the thyristor below its holding current value, different turn-off methods are available. By using any one of the turn-off methods of a thyristor, current passing through the thyristor can be brought below the holding current value. So that's why holding current is associated with turn-off process of a thyristor. The magnitude of the holding current of a thyristor is less than the magnitude of the latching current of a thyristor. It is in milliamperes. Holding current is independent of a gate current of a thyristor. The magnitude of the holding current depends on the rating of a thyristor. We can identify the holding current as well as the latching current of a thyristor on VI characteristics of a thyristor. In this VI characteristics of a thyristor, we can notice that this is the latching current of a thyristor. This is the holding current of a thyristor. From this, it is very clear that latching current of a thyristor is more than the holding current of a thyristor. We can also notice that for different gate currents of a thyristor, the magnitude of the holding current as well as the magnitude of the latching current remains the same. That means latching current as well as the holding current of a thyristor are independent of the gate currents. I thought you understood the latching current and holding current of a thyristor very clearly. Please pass on your comments. Thank you.